Hello students, welcome to Power Tutorials. So let's start our live session on light chapter, which is reflection and refraction, and we are going to cover all the topics fast and I also cover few PYQs as well. Okay, so just give me 2 minutes. Let me just check whether audio everything is fine or not. Okay, yes, I got one comment as well. Yes, I'm going to keep few important questions from electricity chapter. I already covered, so fine. After this video, if you want, I will continue with the electricity chapter as well. You can also check my previous video for electricity. I think 2 days back I have done, or 3 days in the last week itself I have done it. Let me check. It is in video. Electricity. Okay, I have covered only few yes, electricity numericals I have done 3 weeks back. In the live section of my channel, you can check those videos. Resistor questions as well. We want to start with electricity today. Fine then, as per your wish. So I will do with electricity few previous year questions, okay, and then I will cover with the reflection and refraction chapter. Okay, so before going to electricity previous year chapter, let's discuss what is the main topic of electricity chapter, what is the formulas and all. Then I'll discuss the questions of it. Okay, so electricity chapter. First I will write all the main important formula. First one, voltage is equal to rate of work, work by charge. Second, charge Q is equal to IT, that is current into time. Third one, Ohm's law, which is V is equal to IR. And then we have power. Power is defined as voltage into current. So voltage into current, and the second formula using voltage, that V is equal to IR, you can also write this as I square R is also the correct formula. And in terms of voltage and resistance, the power can also be written as V square by R. Okay, and then have the last one, which is energy. They can also ask in the questions that heat is getting released of it, then how to find the questions. So for this, the formula is power into time. So simply just multiply these three with time, you'll get the energy equation, which is VIT I square RT or V square by R into T. So all these four formulas are correct for energy. Okay, and one more thing, with respect to resistors, we have two topics, which is parallel and series. So for parallel, if I say like two resistors like this, one is in this way, R1, R2, then if I ask you what is R effective or R total, it will be like 1 by R effective will be equal to 1 by R1 plus 1 by R2. This is for parallel. Whereas in series connection, you have to remember that two resistors starting of one resistor should be connected with the ending of another resistor. If this is the case, then only it is series. If it is in parallel, both the starting points and both the ending points should be connected with each other. Okay, fine. So this is A part and this is B for suppose, and if I say this is R1, this is R2, then RAB is written as R1 plus R2. Okay, this is for parallel, this is for series resistance. So in parallel, voltage will be same, whereas in series, current will be same. Current will be same when it is passing through both the resistors. In parallel, voltage will be same when it is in parallel circuit. Here, current will be distributed or divided, whereas in series, voltage will be divided. So these two are important things you have to remember for parallel and series circuit. And for resistance, we have one more formula, which is R is equal to rho L by A. So where rho is resistivity, it only depends upon material, it does not depend upon any other things. And the unit is ohm meter. Okay, with respect to, okay, I will just write once again. For work done, it is in, voltage unit is watt, charge unit is coulomb, current unit is ampere, time it is in seconds. Okay, and here these three all done, this three are done. Okay, power unit is watt, WATT, that is watt. Energy unit is watt hour or joules. Both are correct. Okay, those are with respect to units. Excuse me. So resistivity, and L is length of conductor, and A is area of cross section of conductor. Just a minute. Okay, so as you mentioned, I will check few previous year questions, and will also cover the main important topics, like which type of questions will be coming from this chapter. Okay, this chapter is very tough lesson. It's not very tough, I can say that if you remember these 7 formulas. Okay, so these connections, this circuit details, then definitely it is very easy chapter. Okay, so only thing is you have to remember all these points, like parallel circuit, how to find the resistance, how to find the current, how to find the voltage, and if it is mentioned charge, current and time, how to find the details. So those are important. If you remember these things, then it is a very easy chapter to solve it. Okay, so I will start from few basic questions, and we'll go with the previous year questions then. Okay, as you're feeling little tough. Okay, so first one is resistance values for series and parallel. I'll give the questions, I want you to answer it. I will give you a hint as well. Okay, so these are few resistance questions. First one, if I say I have point A here and point B here, and if I say I have 1, 2 and 3 resistors like 1 ohm, 2 ohm and 3 ohm. So if I ask you what is the resistance between A and B, can you answer it? I'm waiting for a response. I just displayed one question, which is 3 resistors, 1 ohm, 2 ohm and 3 ohm. Yes, good. It is 6 ohms. So why? Because it is in series connection. So it is R1 plus R2 plus R3, which is 1 plus 2 plus 3, which is 6 ohms. Now let's take the question to the second level. Now I'll mix a question which is having 2 combinations, resistance and parallel. Now I want you to answer this. If I say this is A point and this is suppose 1 ohm, this is 2 ohm, and now I have another one which is 3 ohm, and again suppose Okay, this is 6 ohms and this is point B. Now if I ask you what is RAB, okay, so here I will give a hint. If we have like these combinations, one as a series and other as parallel, do one thing, solve it separately. Solve this one separately, solve this part separately, and then let's see whether the ending part is combination of series or parallel. Okay, so first solve this one. This one is 1 and 2 ohms, so it is simple. It is just a series. So I want you to answer this value. This already you have done. So this again, this is in parallel combination. These two, 6 and 3. So this I will help you here. For parallel, 1 by r should be equal to 1 by 3 plus 1 by 6. That is 1 by r is equal to, if I take LCM, it becomes 6 plus 3 by 18. So 1 by r is equal to 6 plus 3 is 9 by 18. So 1 by 2. So r will be equal to 2 ohms. This is 2. I want this value now. Good. Total you told it is 5 ohms. Very good. So this total RAB is equal to 5 ohms. Okay. So now let's combine resistors and the voltage, that is Ohm's law question as well. So this is the third part. I can say level 3 type of question. So we have 1, 2 resistors, and now we have a cell here. Cell is nothing but a voltage source which is having some potential. So if I say the voltage is 6 volts, okay, and we have resistors, let's suppose this is 1 volt, this is 2 volts, sorry 2 ohms, and if I ask you find the current flowing in the circuit and also find the voltage at this one, that is V1, and this as V2, okay. And by the way, I'm sir because I used to have my help of my wife as well, so sometimes she also give her voice for shorts, but now I am teaching, so you can refer me as sir. Okay, it's fine. Let's go on. So this is 6 volt source, this is current flowing through it, and I want to find current and V1 and V2. V1 is a voltage across first 1 ohm resistance, and V2 is a voltage across 2 ohms resistor. Okay, so to find current, first I need to get the effective resistance. So these two are in series. So again it is simple. R total or R of the circuit is equal to 1 plus 2, which is 3 ohms. Now I have R value and I also have V value. So what is Ohm's law? Can you write what is the Ohm's law formula in the chart section? Okay, you found the total current as well. Very good. So V is equal to IR, which is 6 volts is equal to 3 into I. Current is equal to 2 amperes. Very good. Fine. So you're doing good with respect to circuits. Fine. Let's increase one more level. Let's make it as a big circuit now. So now we have 2 branches. If I say the source is 10 volts here, I have total 2. Okay, this is 2 ohms, 2 ohms, and then we have 6 ohms, 6 ohms. Okay, and I want to find the total current. At the same time, I also want to get this currents as well. If I suppose this as I1 and this as I2, I want to find total current. This is I total, I1, I2. At the same voltages are not required. Fine. So I just want to find I1, I2 and IT values. Okay, this is question number 4 for now. So any type of question, always remember how much lengthy the circuits might be, because we know that how to reduce it to single circuits. So don't think whether the circuit is lengthy or circuit is like it is becoming looking like complex and all. Just remember it is very easy chapter because everything can be reduced to shorter values. Okay, so this circuit, just modify it and musical tire, very good. So just modify it and then just change to single circuit. So this is a series combination, this again is a series combination. So what will be this circuit changed to? Now this becomes 10 volts, and I want you to answer what is this resistance and what is this resistance. I feel there is some lag in my video, but still hope this part till here it is visible in your screen. Okay, I think now it's visible in the screen. Just let me know what is this ohms, I mean this resistance value and this resistance value, top one and bottom one. Okay, you found the total answer, which is 3.3. Okay, so this is 4 amperes, this is 12 ohms, so 1 by 4 plus 1 by 12, which is 16 by 12 4 is 48, which is 1 by 3. So current is equal to V by R, which is 10 by 3, 3.3 amperes. Very good. So what about I1 and I2? Can you answer those two parts as well? What is I1 and I2? Okay, so I will help you here. As these two are in parallel connections, this one and cell, all three are in parallel. So same voltage will be across these two circuits as well. So here the voltage is again 10 volts and here the voltage is again 10 volts. Now can you answer what is I1 and I2? I'll write out a circuit again here. Four and 12, 4 ohms, 12 ohms. I want these currents I1 and I2. Total current we already found, which is 3.3 amperes. That is correct. I want these two currents. Okay, let me answer then. So this becomes I1 is equal to, voltage is 10, the resistance is 4, whereas I2 becomes 10 by 12. So this is 4 ones 4 5 by 2, which is 2.5, whereas this one becomes 5 by 6, which is 0.8233. So if you add these two values, you get the exact value, which is 3.3 amperes. Okay, why? Because the same 3.3 amperes is getting divided to I1 and I2. So if you add I1 and I2, you should get the same value, which is 3.3 amperes. Okay. I'm not able to get your response. Are you able to hear my video? Just a minute. Let me plug in the supply. Okay, let's continue then. Okay, now I got your response. I1 is 4 by 3, 12 by 3. No, I think somewhere you're doing some mistake. It is voltage by resistance. Resistance is one is 6 and other should be wait, let me see the question once again. You can see here one is 4 and other is 12. Okay, so voltage is same. Okay, let me see whether I did miss some mistake. No, you can see here the voltage is same. Voltage is 10 only. It will not change. Okay, voltage will be same in the parallel circuit, which we already discussed here. In the parallel circuit, I told you that in parallel circuit, voltage will be same. Okay, so in parallel circuit, voltage will not vary. Voltage will be same, but only the currents will change. So that's why here in this circuit, voltage is 10 volts here as well as here as well. Okay, so that's why I1 will be 10 by 4 and I2 will be 10 by 12. Okay, hope you understood. So I'm moving to next type of question. I think with respect to circuits, is it clear or do you want one more question from this topic? Let me know in the comment section if you need one more. Or shall we move to other type of questions? So I want to cover topics related to power now. Okay, good. I got a response. So let's move to the power type of questions. So I will take from previous year chapter. In previous year question paper, I have all the 24, all the set of papers. Just give me 2 minutes. I'll check and get some electricity chapter which is related to power. Okay, I got your response. Now we'll go to power. Good. So let's go to power type of questions. Okay, I'll do one thing. I'll check with the textbook itself. I think there we have so many questions. Just once more checking on previous year's set paper if I get any question on this. Okay, I have an easy question. This is came from the 2024 paper for 2 marks question. Okay, we are going to solve that question now. The question is, in the given circuit, they're just asking to calculate the power of it. So I'm going to paste the same question in this video. So this is a circuit. This is just a 2 marks question, so easy one. They're simply asking to find the given circuit, find the power consumed in watts in the resistor of 2 ohms. Okay, they're asking to find the power at this resistor. Okay, so power formulas we have total 3 formulas, either VI or I square R or V square by R. So you can use either 3 of it. But here, as we have voltage and we have resistance, but this is series resistance. Series in sense the voltage will not be same. If it is in parallel, then definitely I can directly go with the 6 volts, I mean V square by R formula and get the answer. But this is a series circuit. So always remember, for series circuit, to calculate power, you can use I square R or V into I. For parallel circuit, always go with V into I or V square by R. Okay, for series circuit, don't directly use 6 volts by R because 6 volts is not present at this point. If you go with the voltage, exactly find the voltage at this point, then you can go it. Okay, fine. So for this question, let's continue with the power value. So as I told you, let's find the current to the circuit first, and then you can simply use that all. For series, always use I square R formula. For parallel circuit, you can use this formulas. Okay, so for series circuit, I got I square R. So first I need to get the current through this circuit. So this is a series circuit. So simple, R total will be 1 plus 2, which is 3 ohms. To find the voltage, I mean current, using V by R, V is 6, R is 3, so current is equal to 2 amperes. So we have got the current value, have got the resistance value. So which formula I told you, for series I always prefer to get I square R formula. So power at 2 ohms resistors is equal to I square R, which is 2 square into R is again 2, so which is 4 into 2, which is 8 watt. The unit is important because for unit also I think they will carry one off mark. Okay, so always write the units properly. So for this question the answer is I square R, which is 2 square into 2, which is 8 watts. So you understood this question value? Can I get a S please? If you are able to see till here. Okay, so now I understood that live videos will have some lag of 10 seconds, I guess. Okay, let's see if I get a response for 2 minutes, or else I'll go to the next question. In the meantime, I'll check the question paper for another questions. So always remember, for series circuit use the formula I square R. For parallel circuits go for V square by R to avoid any confusion. Okay, because the current and voltages are with respect to their particular resistor, not for the entire circuit. Can I get some yes, whether you understood this question? Okay, I got 5 marks questions. Fine, we'll solve these two now. Okay, I'm moving to the next one. I'm just waiting for a response. I think it is mentioned hi, but I don't know your actual name. So are you there? Can you just comment whether you're able to answer this question? Fine. Okay, so I will solve 2 more questions from this, and then I will go to reflection, light and reflection if I are not answering. Okay, because my main agenda was to solve regarding light and reflection, but as you mentioned regarding this chapter, I'm going to cover few questions of electricity. Fine. So I'm moving to the next one. This question I will solve with respect to power, and if I didn't get any response, then I'll move to the light chapter. Okay. So let's continue. Electric power expressed in terms of potential difference and resistance. Okay, so power, you can say that it is, power is defined as work done per time. So it is a basic definition. So power is defined as the rate of work done. Okay, so rate is nothing but per time. So power is equal to work by time. So if they ask in terms of voltage and resistance, so as we have total three formulas I told you, one is VA, other is I square R, and other is V square by R. So with respect to voltage and resistance, so this is the formula you have to use. So we have to say that power in terms of voltage and resistance is V square by R. So this is answer for the first part. Okay, let's move to the second part. What is they're asking? Electric oven designed to work maintains voltage. Okay, this is a voltage. If oven consumes 11 units of electrical energy in 5 hours, they're asking to calculate these three. Okay, so now this is related to power and energy concept also, which is the last topic from the chapter. That is energy's part. Okay, so what is energy formula? Energy is equal to power into time. So always remember, if they mention energy as 1 unit in sense 1 kilowatt hour. This is important. Okay, so what they have mentioned here, mean voltage is 200, voltage is 220 volts, energy is 11 units of electrical energy, so E, that is energy, is equal to 11 into 1 kilowatt, which is 11 kilowatt hour. So this is energy. And time they have mentioned, what is the time they have provided? Time is equal to 5 hours. Okay, we have voltage, we have energy, we have time, and then what you need to find, we'll see. The first one is power rating of the oven, current and resistance. So we need three: power, current and resistance. Okay, so for what is the power formula? Power is equal to energy by time. So what is energy they have mentioned? 11 kilowatt hours. So it is 11 kilowatt hours by time is mentioned 5 hours. So R cancel. So it is simple. 11 by 5 kilowatt is the power value. Then they are asking current. Power, we have another formula which is V into I. So simple, you can find the current, because current will become P by V. Power we got 11 by 5 kilowatt by voltage is 220. So if you divide by 11 table, 11 ones, 11 20s, so it becomes 1 by 100 kilowatt. So kilowatt by voltage, which is ampere. So 1000 is kilo. So 1000 by 100 ampere, which is 10 amperes is current, because I just converted kilo to 1000. So we got power value. So always remember to box the answers, because the invigilator will directly see the answers sometimes, and they can directly get you the full marks. Okay, but still the steps are important, but at the ending part always remember to box your answers. Okay, and the last one, you need to find the resistance value, which is R value. So we have the power formula, which is V square by R. We can use this here. So power, we got it as 11 by 5 kilowatt. Voltage square, which is 220 into 220 by R, is equal to 11 by 5, 11 ones, 11 20s. So R is equal to 20 into 220 into 5, and this is in kilowatts, so by 1000 to get in terms of ohms. So let's divide it now. 1 2 1 2, and 5 2 is also 10, so R is equal to 22 ohms. Got it? So we have covered the energy part, power part, and the resistance part as well. So there can be a few questions with respect to resistance formula, which is rho L by A, only that is pending. So I think those are easy questions, so everyone should be able to solve them. Okay, so but just for as I covered all the other topics, I'll just try to write the formula as well. R is equal to rho L by E. So they will ask you in the questions saying that material is same. If material is same, rho is same, that is resistivity is same, they'll simply say that length is doubled, length is doubled, area is 1/4 of previous one. They will ask you to find new R2. So this, for to solve this type of questions, what you have to do is just write all the formulas here and get the R value. So now if I write R2 is equal to R is, I mean, material is same, so rho is same, length is doubled, so now it becomes 2L, area is 1/4 if you ask, and then it becomes 1/4A. So if I write 4 to the top, it becomes 8L rho by A. This is again the previous value, which is R1. So R2 will become 8 times of R1. So to solve this type of questions, just follow this method. Just they will say that length is doubled, area is half, or they can mention any other values as well. So based upon the value, just substitute in the place of L, rho and A, you'll get the final result, which is in terms of resistance R2 in terms of R1. Okay. Fine. So as I thought of to start with the light chapter, so I'll give a small intro about light chapter, and then in tomorrow videos I'll try to cover the questions related to this chapter, light chapter. Okay, but as someone requested with respect to electricity chapter, I have covered all those topics here. Fine, let's move to the light chapter, and few things I want to cover today, that is for another 20 minutes. So for light chapter, the first important point is reflection. So what is reflection means? If a light falls on a mirror, it gets reflected, that is reverted back from the mirror. So simply we have total 3 types of mirrors. Plane is one, and spherical mirrors also we have, which are 2 types, concave and convex. Okay, so for plane mirror, it is something like this. If a light falls on it, it gets reflected the same. Or else if light is falling at an angle, it also reflects in the same way. So this, if I say angle of incidence, and this same will be angle of reflection. This is for plane mirror. For concave mirror, the mirror will be like this, that is K from the left side, and for convex mirror it will be like this. So concave will be like, convex will be like this, whereas concave will be like this. So these are the 3 mirrors we have for reflection. So what is the loss of reflection means? We have 2 loss of 2 points for loss of reflection. This is very important for 2 marks question. They can ask you for what is loss of reflection. You have to say that first one, incident ray, reflected ray, and normal lies on the same plane. Second, angle of incidence is equal to angle of reflection. Okay, that is theta I is equal to theta, that is angle of reflection. Incidence is equal to angle of reflection. Okay, fine. Just 2 minutes. Okay, I think there's some issue with the connectivity. Fine. Hope you're able to see my screen. Let me check with my phone whether everything is fine. Okay, I'm able to see the screen properly. Fine. Let's continue. So this philosophy of reflection got done. Then let's see for concave and convex mirrors. So how the reflection happens and if, with respect to position, how it changes. Okay, for mirrors we'll cover today, and for lens and other topics we'll continue tomorrow. Okay, so for concave mirror, so let's understand about few things. If light falls on the concave mirror, so directly covering with respect to positions. First position, if object is at infinity. If object is at infinity, what happens to the image? If object is at infinity, suppose like this, so the main property of concave mirror is if any line is passing parallel to the principal axis, so this is okay, I'll give the points. This is principal axis. We have a point which is P here. P is nothing but pole. Then we have two more points which is focus and other is center. Center in sense, first if you suppose this is as a sphere part, then the center of the sphere is the center, whereas focus is if any lens is passing parallel to the principal axis and get reflected at one point, that point is nothing but focus. So as I was saying, this is a focus here. So another line, this also will be reflected through the focus. So object is infinity, image is diminished, like point sized. Diminished is point side only, okay, and this is the left side, so it is real, and we cannot say it is inverted because it is just a point, but still we can say it is not even flat as well. Okay, so it is an inverted, so this is at point if it is at infinity. So this is the ray diagram. If they ask you for infinity how the ray diagram will be coming, you have to mention in this way. Okay, so next move to the next question. If I see if the object is beyond C, what will happen? Same mirror, we have position F, we have position C. Let's place the object here. So the first point, let's draw a line which is parallel to principal axis. Definitely what will happen, it will reflect through the focus. Okay, and the second, if we will draw a line passing through focus, what will happen, it get reflected, it will be parallel to principal axis. So you can see if this is object, AB is the object, then we'll get the image A dash B dash here. So this is the image. I will just mark with another color. So this is image. Orange line is the image. Okay, so this is AB which is here, and this is focus points and all. So here object is beyond C. What happens to the image? Small size. If you compare, this is object, this is image, so this is small size. Where is the image? Between C and F. What is the nature? Real and inverted. Okay, with respect to the next point, if the object is at C, we have focus, we have center. If object is at C, now see what will happen. We have to draw a line parallel to principal axis, it will get reflected through focus. The second line, if it is passing through focus, it will get reflected to center. So same, these two lines will get intersected at this point, and at C itself the position, the size will be exactly same. So with respect to object at C, image, okay, this is object, respect to image, also at C, real and inverted. The size is same size. Okay, could see that video is getting lag more now. Fine. So what I will do is I will stop here. So whoever is watching this video, you can check this video again and let me know if you have any doubts with respect to this. And tomorrow, instead of live session, what I will do is I will keep a recording session and I will complete all this chapter, light, reflection and refraction, so that there will be no lag and you will not get to have any disturbances. Okay, so I'm going to stop at this point. So till 3 points I have covered, that is infinity, beyond C and at C. So tomorrow I will start with the video. I will start with the point which is between C and F. If the object is placed, what will happen? At focus, what will happen? And between focus to point P, which is at pole, what will happen? So those three will cover along with other topics like convex mirror and few questions related to mirror formula, which is 1 by U plus 1 by V is equal to 1 by F. So that formula also will cover. So let's meet tomorrow, and mostly I will try to schedule before 8 p.m.